Welcome to the Deep Dive. Today, we're firing up a discussion on TIG welding, specifically looking at different approaches for, tackling stainless steel.
Right.
And look, you might be thinking, welding, that's pretty niche. And yeah, okay, it is a specialized skill.
Definitely. But what's cool about these deep dives is finding those core ideas technique, adapting, solving problems that really apply everywhere,
Exactly. So today, it's about getting into the weeds of technique, how skilled folks adapt, and that problem-solving mindset. Think of it like a peek behind the curtain. I bet you'll see parallels.
You bet. Our mission, really, is to understand the differences between these two tip methods for stainless steel that controlled walking the cup versus freehand, maybe using that TIG finger tool.
Right. When would a welder pick one? What are the pros and cons? We want to get a feel for the decisions behind a quality weld. Okay, so let's start with walking the cup.
Okay, so the video starts showing this first pass using walking the cup. But interestingly, they point out it's not really a walk initially, it's more a wiggle.
A wiggle,
Yeah, the welder in the video actually says they're just wiggling the cup back and forth. And this leaves these little scratch marks on the metal surface.
Ah, okay. And they immediately flag that, right? Those marks mean you can't use it everywhere.
Precisely. Like if you're in semiconductors or dealing with finely machined parts, those scratches, absolutely not acceptable.
Yeah, that makes sense. It shows how even standard techniques hit limits, doesn't it? You got to adapt or switch based on the job's constraints, like surface finish.
It's a great point. Even within one technique, there are variations for different standards. But they do mention for like pipe fitters, construction guys doing socket welds on pipes, this wiggle or walk is pretty standard stuff.
Right, maybe speed is more key there, and the finish isn't as critical.
Yeah.
So why is it popular then? What are the actual advantages?
Well, the main things seem to be maintaining a really consistent torch angle and just a very steady, repeatable movement. Every little wiggle moves the weld forward pretty much the same amount. And that gives you that nice, even pattern of ripples in the weld bead. It's almost like having a physical guide for your hand, helps keep things consistent.
Kind of like training wheels for steadiness. But there's a big catch, isn't there? It only really works well when...
Yeah, exactly. When there's nothing in the way. You're making these sort of rhythmic movements with the cup touching the metal, so if anything's sticking up, it just messes up that smooth travel.
Right, totally disrupts it. The video shows it on a pretty clear piece, I noticed.
Yeah, nice open space.
Okay, so that's the first pass, the wiggle. Then they show a second pass, and the technique changes a bit.
Yes, for the second pass, the description changes. It's less wiggling, more like walking a 55-gallon drum across the floor. That's the analogy they use.
Huh. That's a great visual. So, still using the cup as a guide, but more of a rolling motion.
Exactly. You tilt the cup side to side as you move along the joint.
Okay. And what's the goal there? Does rolling do something different than wiggling for, like, heat or the bead shape?
The aims are pretty much the same, actually. It still helps keep that electrode angle right, keeps the arc tight and focused, and again, promotes that consistent forward movement, those even ripples.
Wow.
The idea is that by physically rolling the cup, your hand just naturally follows a steady path.
But just like the wiggle, they point out this rolling thing isn't always possible either. Depends on the situation.
Right. Another constraint. The shape of the joint itself or stuff nearby could make that rolling motion really awkward or just impossible.
So in the video, they do a root pass, then these two walking passes. 3 total. Is that typical?
Not always. They do say sometimes you need more than 3 passes, definitely. Depends on how thick the metal is, what the specs are for the weld, that sort of thing.
Gotcha. Then the video kind of shifts to the gear they're using, this rigid #17 air-cooled torch. What's the deal with using that type of torch for walking the cup?
Well, being rigid can be a bit limiting, especially trying to get the right angle sometimes.
Yeah.
Since the head doesn't bend or swivel,
Right.
the welder sometimes has to kind of twist their hand around or even prop their hand right on the workpiece to get the torch pointing correctly. You actually see them doing that, propping their hand in the video.
Huh. It's interesting how the tool itself forces you into certain techniques or workarounds. Okay, so they show walking the cup, mention the torch limits, and then introduce this other thing, the TIG finger.
Yeah. This is where it gets interesting. A tool designed to solve specific problems. It's positioned as the solution for when you can't walk the cup or when you just need more stability and, crucially, heat protection.
Okay, let's break down those uses. First up, small diameter tubing.
Okay.
Why is the TIG finger good there?
Yeah.
Walking the cup is tough, right?
Yeah, impossible really. The curve is just too tight. There's no flat surface for the cup to glide on. So the TIG finger gives you a stable spot to rest your hand, lets you slide smoothly around the tube without needing the cup for guidance.
Makes sense. And they mentioned student practice joints, especially aluminum. What's the issue there?
Aluminum heats up fast and holds onto it. Plus, it can warp. So for students doing multiple passes, that metal gets super hot.
Ouch.
Yeah. It's hard to prop your hand on it comfortably. The TIG finger acts like a heat shield, protecting their hand, and gives a stable resting spot. Better control, less discomfort. Plus, aluminum can be kind of slick too.
Good point. Okay, outside corner joints were another one. How does that help there?
Outside corners can be awkward to prop on steadily. The TIG finger lets you rest comfortably along the edge. They even show turning the torch upside down and using a pinky on the device for extra support. Gives a much more solid platform.
And what about tight spots?
Yeah.
Inside corners, T-joints. They mentioned trapped heat.
Exactly. Heat gets trapped in those corners, radiates back, can really cook your knuckles. The TIG finger provides that physical barrier, that insulation, lets you get closer, weld more comfortably in those tight hot spots.
That seems specific, but it links back, doesn't it? Comfort and safety, whether it's heat protection here or like ergonomics for someone at a desk, they directly impact focus and precision.
Absolutely. It's all connected. They also mention using it on 4130 chromoly, like for aircraft parts.
Right. Aircraft fuselage is why there.
Well, aircraft structures often have really complex shapes, tight access, hard to find good spots to prop normally. And 4130 gets pretty hot too. So the TIG finger lets you prop right near the weld in awkward spots, gives stability, and shields from heat where you just couldn't prop otherwise.
So the big picture for the TIG finger is it gives you a steady rest and heat protection when walking the cup just isn't going to work or isn't practical.
That's the core of it. They even compare it to like an old school workaround, cutting the thumb off a TIG glove for a propping point. The finger is just way better, purpose-built.
Right.
And interestingly, they mentioned some people even use it occasionally in stick welding for tricky stuff, like small pipe in a tough position. Shows its versatility for just getting a stable rest.
Definitely highlights having a dedicated tool for that. Okay, then the video switches gears again. Talks about another torch, the CK Flex Lock. How does that tackle the angle problems we talked about with a rigid torch?
Ah, the flex lock. Yeah, that's shown as a big improvement for maneuverability. The key thing is its flexible head. It lets the welder basically bend the torch to get, as they say, absolutely any angle needed.
That sounds incredibly useful, especially for awkward positions. How does that help in practice?
Well, the video shows how much easier propping becomes. You can bend the torch head to find a comfy, stable spot for your hand, which lets you get a better welding angle, no matter how you're positioned or what the joint looks like. It really shows how tool advancements focus on adaptability, Even good tools have limits.
Yeah, definitely. And it looked like they were using it with something else. A stubby gas lens kit. What's that about?
Right, the stubby gas lens. Okay, think of the regular gas lens like a standard nozzle on a hose, directing the shielding gas. The stubby kit is a better nozzle. It gives a more focused, even flow of argon gas to protect the weld puddle, especially in tight spots where good coverage is critical.
Okay, better gas coverage.
Yeah, and the stubby part just makes the whole front end of the torch smaller. So that bigger #17 torch feels more like a nimble little #9 torch, more agile. Combine that with the flex head, and you've got a really versatile setup for tight spaces and getting perfect angles.
Okay, so we've got walking the cup, the TIG finger for problems, the flex torch for angles. Then they show freehand welding, no cup involved.
Right.
What's the context for that in the video?
In this demo, they use freehand for the final cover passes. Those are the ones you really see on the finished weld. So appearance, the consistency of the bead, that's really important then.
Right. And what's harder about freehand compared to using the cup as a guide?
It really comes down to maintaining super consistent hand movements. Without the cup guiding you, you need really good dexterity, focus, control. To keep the travel speed even, the torch oscillations steady, that's what gives you those nice uniform ripples.
Yeah, it takes serious skill.
Totally. The video even shows like a split second where the hand movement wavers a tiny bit. It really underscores the concentration needed.
But they make a good point, right? A tiny slip isn't the end of the world. They show how to recover.
Exactly. It's realistic. Even experts have tiny inconsistencies. The skill is recognizing it and adjusting immediately to keep the weld quality up. Great example of adaptability, even mid-weld.
And they give the specific settings for those freehand passes too, right? What were they using?
Yeah, let's see. They were using an 18-inch filler rod, machine set at 130 amps. The electrode was a 332-inch, 2% thoriated tungsten, though they mentioned they usually prefer 2% lanthanated for stainless, generally. And the shielding gas was argon, flowing at 20 cubic feet per hour through a #7 gas lens cup. That argon is key, stops the air from messing up the molten weld. All those choices, filler size, tungsten type, amps, gas flow, they all matter for how the weld flows and looks, kind of like picking the right brush and paint consistency, you know?
Right, everything tuned for the result. Okay, and finally, near the end, they mention heat buildup. By the last passes, that stainless steel piece is pretty warm. How does that circle back to the TIG finger?
Yeah, it really drives home that benefit. When you're doing multiple passes or just welding hot, the workpiece heats up a lot. Having that TIG finger, that non-conductive layer between your hand and the hot metal, makes a huge difference. It lets you keep welding comfortably, maintain that fine motor control without, constantly pulling back because it's burning hot, right?
So wrapping up this deep dive, we've seen two main paths for TIG welding stainless. Walking the cup, great for consistency when you can do it, but has limits, might leave marks. And then freehand needs more skill, but more flexible, especially with tools like the TIG finger for stability and heat protection.
And what's fascinating is realizing that picking a technique isn't just like random preference, it's calculated based on the job, the material, the finish needed, obstructions, even the specific tools you have.
Right.
The real aha for me is seeing how small things, the torch type, that TIG finger, can make such a big difference in doing the job well, efficiently, and importantly, comfortably.
Totally agree. It really makes you think about any expert field, doesn't it? How pros develop and choose specific methods and tools to get the job done and handle challenges. It begs the question, what are the walking the cup and TIG finger equivalents in your work? Yeah. The standard methods versus the clever solutions for specific problems. What can we all learn from this welding deep dive about mastering any skill, even if it seems totally different? Definitely food for thought. Thanks for joining us on this deep dive.